The step number one is to understand what is a disaster. Let's suppose you hosted your application in a region and unfortunately that region met with a natural calamity or disaster, like a flood or earthquake. Or it could be a data center that lost power, or due to cable damage, it lost the network connectivity. Or it could be the most common disaster, that is human action, like someone actually planned and plotted a bad configuration, or it could be damage due to unauthorized access by deleting your data, or even it could erase all your customer information. And that's where we reach to our step number 2, that is high availability is not disaster recovery. So why are we saying that high availability is not disaster recovery? You might think both are the same, because both of them start with the same operating principles. First, both monitor for failures. Second, both deploy the resources at multiple locations. And third, obviously, is automated failover, where if one data store or resource fails, you have the backups to take over. But think rationally about the steps that you take for high availability. So when it comes to availability, you are more focused towards the components or resources of the workload to serve the customer demand. And so that you can operate continuously without failing, and you strive hard to meet the service level agreement of service availability. And on the other hand, when it comes to disaster recovery, you need to focus on the time it takes to recover from a disaster. You need to ensure the workload or resources that you have provisioned meets your availability objectives. And the focus is rightly on deploying discrete systems to multiple locations. But the main objective here is also to have a multi-site active-active workload distribution. So multi-site active-active is a disaster recovery strategy to run the workload that you have in a way that it can serve requests in 2 or more distinct data centers or regions. So this strategy enables your workload to remain available despite disaster events such as natural disaster, technical failures, or human action. And point-in-time backup, so which enables you and your customers to recover the backup data from a specified time within the retention period that you have set. So let's suppose you have your application hosted on a region with multiple availability zones with a proper scaling mechanism. Your users are very happy with the application status. If one of these availability zones, that is data centers, get affected and stops responding, so a load balancer is smart enough to route the traffic to other instances in other availability zones. And your users are still fine as they are able to access the application. But what if the whole region gets affected? What is going to happen? In simple words, your high availability is now zero availability, isn't it? And that's where disaster recovery might come in handy, because disaster recovery might tell us to have a deployment strategy of multi-site deployment, that is like deploying it in other regions as well, as shown here. If your application is not responding on the region, it can as well respond using other regions. I know you might still have doubts regarding this, so just keep watching, and I'll tell you one thing. One of the best ways to avoid disaster is subscribing to this channel. That's my disaster recovery mechanism, and it's free. So having said that, let's move on to our third step. The third step is, are you resilient enough? So when you think of trust in terms of your product, you should always remember the word resiliency. This word resiliency in its actual sense refers to the capacity to recover quickly from difficulties. So it's same when it comes to your infrastructure as well. So resiliency is the ability of a workload to recover from infrastructure or service disruptions and dynamically acquire computing resources to meet demand and mitigate disruptions such as misconfigurations or transient network issues. Always remember that things can go wrong at any point in time. But the most important thing is how fast you can recover from the disaster. That's where resiliency strategy comes into the picture. So if you see here, disaster recovery and availability are a very important part of our resiliency strategy, where disaster recovery focuses on how workload responds to disaster and how well it can recover from that. On the other hand, availability focuses on uptime or downtime for your resources over a period of time, also known as mean value over a period of time. So when it comes to disaster recovery, if you see here, the response actually depends on the business objective and how you can avoid loss of data. That is also known as the recovery point objective, that is RPO. And the other thing is how well you can reduce the downtime for your application where your workload or resources are not available for use, which is also known as the recovery time objective, that is RTO. As I already told you before, availability focuses on uptime or downtime for your workload or your resources over a period of time, also known as the mean value over a period of time. Remember, it's mean value. I'm sure that most of you are totally aware of what a mean value is. So we have to focus on mean time between failures, that is MTBF, and mean time to recover, that is MTTR. In order to understand how we can calculate the availability, you need to understand how to calculate MTBF and MTTR. So first let's check MTBF, mean time between failures. Here you have to calculate the total working time of your application minus the total time of your application breakdown and divide it by the number of breakdowns that you had. So like let's suppose you had a total working time of your application that you have hosted as 100 hours, and out of which you had 5 hours of breakdown time. So breakdown time, imagine it is a time period where your users were not able to access your application, and there were 10 breakdowns in total. So your mean time between failures will be 100 minus 5 hours of breakdown time divided by 10 breakdowns. So that is 9.5. And similarly, if you have to calculate MTTR or mean time to recover, you have to check how much time did you spend to bring up your services or application and divide it by the number of repairs that you had to do. So for example, you spend around 10 hours in maintenance and it was around 5 times that you had to repair the system. So MTTR will be 10 divided by 5, that is 2 hours. So now that you're aware of these terms, let's calculate availability. Yes, availability is basically, as the word tells you, it's the amount or percentage of time or value on how available your services or application is to your user. But you have to remember that it's not always that a disaster should occur to impact availability. It could be like, for example, you have created an application design that supports a maximum load of 100 users. But what will happen if you get around like 10,000 user requests at the same time? So you would ask yourself, why is it not working for your application to support that amount of load? There is no calamity or earthquake or flood. Still, your application is not available to all the users. So you have to take some steps to improve that, isn't it? I think you already have the answer to this, and if you do, please make sure that you put that in the comment section below as what you feel availability is according to you. So now let's get back to this. So availability is a measure to calculate the amount of time that your application is available for use divided by the total time or total amount of time it has been hosted. So internally it is translated to mean time between failures divided by the total of mean time between failures and mean time to recover. So it is MTBF divided by MTBF plus MTTR. And you might have heard or read about this term called availability in terms of nines. So like 3 nines or 6 nines. So where 99.9 is 3 nines. So this is one of the most desired availability that services are trying to achieve. So let's suppose we have a MTBF or mean time between failures that is around 400 hours and MTTR, that is mean time to recover, as 10 hours. So if we put that into the formula that we have above, so we'll get the availability is around 400 by 400 plus 10, that is 400 by 410. So you'll get a value of 0.975. So you get availability of 97.5%, which is not that great, but this is just an example. So I'm just showing you how actually the calculation works. But availability can be measured with the response as well and not just time. So let's see how it works. So here availability is the number of successful responses divided by the number of valid requests. So for example, you get successful response as around 500 responses and you have a valid request that you have sent, that is 510 requests. So availability for you will be 500 by 510, that is 0.98. So if you convert that into percentage, it is around 98. So 98% is good, but this is just an example. I just wanted to show you. The first step that we have here is the resiliency of the cloud. So what AWS tells us is that resiliency is a shared responsibility between AWS and you, the customer. So you must understand how disaster recovery and availability works in the shared responsibility model. And I'm sure you have already seen this in the security pillar that we have discussed before, We had already discussed the shared responsibility model, and I hope you will relate to that. So first thing that you have to understand here is the phrase resiliency of the cloud. So all the infrastructure that you see here, the hardware, software, networking, and the facilities that run AWS cloud services and its resiliency is the responsibility of AWS. So all these things that you see, the hardware, software, networking, and the facilities, and all the services that are run on AWS cloud and its resiliency is the responsibility of AWS. So if you're not able to launch an EC2 instance due to a region failure, it's AWS's responsibility to bring that up. But if you lost your data that you had in your data stores and you didn't plan for disaster recovery, that is also the responsibility of AWS, isn't it? No, you're wrong. That is your responsibility to safeguard your data and to have disaster recovery in place. That's not AWS's responsibility. Your data is your responsibility. And that's where we have to go to our fifth step. Step number 5 is resiliency in the cloud. I will tell you one statement and it will sum up this step, and that is your responsibility will be determined by the AWS cloud services that you select. Does it make sense? So let's move on with this. So here, if we have to take an example, so AWS gives you a service called Elastic Compute Cloud, that is EC2, but it's your responsibility of what you host there and the data that you store. If you don't host your application in multiple availability zones for high availability, it's not AWS's responsibility that your application went down. It's your responsibility. If you are using ephemeral stores, it's not AWS's responsibility that you lost your customer data. The configuration that you have is your responsibility. The encryption of data is your responsibility. Hosting your application in multiple regions and having a failover is your responsibility. I hope you got the point here. If you did, let's move on to the sixth step. The sixth step is Business Continuity Plan, or BCP. So what AWS tells us about BCP is that your disaster recovery strategy should be based on business requirements, priorities, and context. So you might ask me, what is BCP or Business Continuity Plan? So Business Continuity Plan is the process involved in creating a system of prevention and recovery from potential threats to the company. So you might be thinking we'll have a disaster recovery in place and it'll work fine and it'll have no issues, but it's not always the case. I'll tell you a few scenarios or situations where the BCP strategy or disaster recovery strategy can be of very less impact. So let's suppose you are selling a product online and you have a multi-AZ and multi-region setup to help disaster recovery. As I already told you, that product was launched with a particular flavor, and that flavor caused a lot of allergies after 5 days of use. But you already had sold 50,000 units and your business outcome depends on that now. In this situation, only God can save you. No disaster recovery strategy can save you. You might be thinking, I'm just launching an EC2 instance. How will it impact me? So if you're working on a project or application at your office or startup, for you, it might be an application where you're implementing some features and writing some code. But for the people who make the decision to allot a budget on your project, for them, it's a product from which they're expecting to make money. It's a business for them. They're not doing it for a charity. So when you design an application on the cloud or infrastructure, the cost and budgeting are a business constraint, and it will be approved by the people sitting at the highest order. And that is why your disaster recovery strategy should be based on business requirements, priorities, and context. When creating a disaster recovery strategy, we must plan for recovery objectives. And they are recovery time objective, RTO, and recovery point objective, that is RPO. So imagine this is the timeline and this is the point of the disaster. Listen to this very carefully. Recovery point objective, or RPO, is the maximum acceptable amount of time since the last data recovery point. So this is your recovery point. What it means is that between the disaster and the recovery point using which you can recover your data, this period that you see here is the amount of data that you can afford to lose. That is why that period here is mentioned as data loss. That is why it is mentioned here that it is the maximum acceptable time or acceptable amount of time since the last data recovery point. So as an organization, we define what is considered an acceptable loss of data between the last recovery point and the interruption of service. That is why it is called a recovery point objective. So we have to define this objective. And there is another objective that we have, that is called the recovery time objective. So RTO is the maximum acceptable delay between the interruption of the service and the restoration of the service, from the time that it went bad till the time it went to the acceptable state. So as an organization, if you define that 1 hour is the RTO or the recovery time objective, then within that time, you should be able to restore your service from interruption. That's the acceptable amount that you have. So the time frame that you see here, is the acceptable time window for service interruptions. That is why it is mentioned here how quickly you must recover and what is the cost of the downtime. So now that we have the intro in place, let's talk about these in detail in step 7 and 8. So our step number 7 is recovery time objective or RTO. So what you see here is the cost and complexity versus length of service interruption graph. So as we know, RTO is the maximum acceptable delay between the interruption of service and restoration of service. But in order to give the user the best possible resolution, the cost to business will remain the biggest differentiator. So you might ask me how, and for that I'll tell you a very small example here. So please listen to this very carefully and you decide what exactly is the differentiator. So I'm going to give you an example here as to how you should imagine this graph. Let's suppose I give you a device that is broken and I ask you to repair it. And you tell me that it will cost you around $100 and it will take 5 hours for you to get it repaired. Okay, that's good, but I want it to be repaired much faster. So I visit another shop, a person, and ask him to repair it. So that person said that he or she is going to charge me around $500 and it will be repaired in 1 hour. So this is very good in terms of time, but I don't have $500. So it's something that my business cannot afford. So I visited another repair shop and he said, I'll charge you around $250 and it will take you around 2 hours to the repair to be done. So that sounds reasonable, isn't it? Based on the time and cost it provides me. So now tell me, what was the deciding factor here? Was it the cost or was it the time? Yeah, it was both, but in consideration with my business outcome. So I can afford to pay $250 and wait for 2 hours of service interruption. That's the maximum acceptable delay between the interruption of service and the restoration of service. And this is your length of service interruption in time scale. And this is the amount of cost and complexity of the process to bring the service back to life. And this is the cost of business impact. And each disaster recovery strategy will fall into one of these categories, as we have mentioned here. So the first one is multi-site, that is active, where you create a second active replica setup of your service, and which is one of the best when it comes to time, but too much for the cost side because it exceeds our acceptable recovery cost. So the next best approach is considering the time factor, that is warm standby, where you have a scaled down version of a fully functional environment that is always running in the cloud. This is optimal for disaster recovery, but reasonable on cost as well. Next comes pilot light disaster recovery strategy. So in pilot light approach, the most core components and services of your application are replicated in another region, like your most important data and storage replicas, and other services are turned off and only used when testing or only used during testing. So that is pilot light. And when you face any challenges, then you can rapidly launch the whole setup when you need it. So this is very good when it comes to cost and also reasonable when we consider the recovery time objective, as it falls within the criteria. Then comes backup and restore, which is like extreme cost saving, but also provides a very slow recovery time. So here you back up your data and application from anywhere, like other location or on-premise to the AWS cloud for your application usage. So this will surely take a lot of time because you have to set up everything in another location. But having said that, it's not that you're going to choose multi-site active always to save time. No, you should not do that. the disaster recovery approach depends on your business outcome, as I told you. And it does not make sense in most of the cases, because to run a full-scale setup across multiple regions or locations, you have to pay an enormous amount considering the cost. So think about what fits best for your business before taking into consideration any of these approaches. But if you see here, as per the graph, the warm standby and the pilot light are very good approaches when it comes to cost and time. So the concept of active-active and active-passive is very important considering the exam. So easiest way to remember this is to imagine it in a way that in active-active, you have a replica of your application running in another location or region always. So the whole setup is available to you. That is why it's active on one location and active on another location. And you can route traffic to any one of these regions that you have at the same time. So when it comes to active passive, you should remember that one location has an active setup running, but you have another location or region where you are running your scaled down version or minimized version of your application or even your actual setup as well, but they are not active at the particular moment. So only one is active at a particular given point of time. So that is why it is active passive. Now let's come back to the diagram here. So here, as we already discussed, backup and restore takes hours of restore. So it takes hours to restore. So that is why it's just for low priority use cases or less critical workloads. And you provision your workload post the disaster that has occurred. And this is the lowest cost disaster recovery. And as we move forward, we come to Pilot Light. So as I already told you that in Pilot Light, most core or critical components and services of your application are replicated in another region, like your important data and storage replicas, and other services are turned off and used only during the testing time. So here you have live data, but considering some of the services are kept idle. So it might cost you more than backup and restore, but it will surely take less time for your recovery process. Then we come to the next active passive disaster recovery strategy or setup, that is warm standby. So here your services on another location or region are always running, but it's a scaled down version of your actual setup. So this is very good for business critical applications. And when you have a disaster, you can scale up your resources. And obviously it will cost you more than the previous two setups that we have, but it is reasonable with recovery time. And the recovery time is in minutes. So it's a very good option as well. So next is the best disaster recovery strategy, but it costs a lot more than any of these other disaster recovery strategies, but you get zero downtime and zero data loss in multi-site active-active. So try create a balance between recovery time and cost as per your business requirement. And that's what I would suggest. Now we have the step number 8, that is recovery point objective, that is RPO. So here as well, when it comes to RPO, that is the maximum acceptable amount of time since the last data recovery point. So to remember this, imagine this scenario. Whenever you create a data set, you keep a copy of that in another location so that in case you lose the original data, you have a backup from which you can recover your lost data. So imagine someone tells you that they will keep a replica of your data every second. And in case you have a disaster, you can recover your data that was lost up to 1 second of the time when the disaster occurred. So you'll be very happy, isn't it? But when he says he will charge $500 for every replica that gets created, then you will be taken back and you might feel it's too costly, isn't it? And another person tells you you will have zero data loss, but you will have to pay $1,000 for the amount of data that is being replicated. So you might be really excited about this, but this will be beyond what you can afford or your business could afford, isn't it? In some cases. So here as well, you have to consider what your business outcome is, and based on which you have to take the decision of which disaster recovery strategy should you choose. So here we have the graph of cost and complexity versus data loss before service interruption. Remember this point very carefully. We are talking about data loss before service interruption. So having said that, we all know that with multi-site active-active, you get near zero data loss because you have near real-time data replication. So it may be around in seconds. But backup and restore is considered to be most efficient when it comes to cost because your backups are created in the same region as their source and are also copied to another region, but it gives you the most effective protection from disasters. You might ask how? Because you have the data backed up and you can restore it into another setup. But the thing is that it'll take more time. That's the only problem. But the interesting thing for us is to see that both warm standby and pilot light have similar data loss, but the cost and complexity is less for pilot light compared to warm standby. And you will ask me why? That's a good question. So here both of them use near real-time data sync because both of them have live data with periodic backups. But the difference in recovery cost comes because in pilot light, most of the services are turned off or are kept idle compared to warm standby, which has a scaled down version of its actual application. So I hope you got the point here. So now we reach to our step number 9, the most important one, that is disaster recovery options in the cloud. So let's talk about disaster recovery options in the cloud with a few more detail. So we have already discussed these options before, which are available to us ranging from the low cost and low complexity of making backups to more complex strategies using multiple active regions. So let's talk about them one by one. The first thing that we'll talk about is backup and restore approach. So as the name tells you, the approach in this will be to take the backup and restore it to another region along with the infrastructure that you have. So that's a very straightforward approach, isn't it? You take the backup and restore everything or the infrastructure along with that in another region. So this is your active region where you take your backups, and this is your DR region, that is your disaster recovery region. The RPO is the recovery point objective that will depend on how frequently you take the backup, and that's where your point in time backup helps you. For that, we are using Amazon S3, which gives us the feature of S3 cross region applications. So we are storing EBS snapshots and the DB snapshots on S3, which will be replicated across the region using CRR. And with the help of AWS backup, we can also copy our backups of our configurations across regions. And the importance of backing up configuration is that it will help you launch your infrastructure using that configuration with CloudFormation or any other IAC that you're using. And it is advised to use a different account for your disaster recovery region that you have here. So in case your account gets compromised in here, it does not get affected to your other region. But even though you use AWS backup to restore the data, it cannot be done automatically. Or the restore cannot be done automatically. So in order to do that, we have to make use of AWS APIs to automate that. When it comes to taking backup and taking restore, what we can do is we can create jobs using APIs, which can be executed periodically in time based on a trigger point. So the AWS backup sends the notification about the job once the backup is completed. So it gets notified to the user using the AWS SNS notification service. Then using the SNS, we can trigger the job by invoking Lambda function for testing, restore functionality and cleanup actions, based on which we can perform the restore operation and cleanup for the EBS block storage. So I'll repeat it once again. So what we can do is we can create jobs using APIs, which can be executed periodically in time based on a trigger event. So AWS backup here will send the notification about the job once the backup is completed. So the user will get notified along with that using that SNS notification service. And then SNS, what it will do, it will create a trigger to execute the job by invoking Lambda function for testing restore for a backup and the cleanup functionalities and actions. And based on that, we can perform the restore and cleanup of the EBS block storage. Now coming to Pilot Light, as we have already discussed, here we have the database and storage always active, but the application servers which contain the code and configuration are turned off or kept idle. So I've highlighted important pointers here for you to keep your focus on that particular thing that is important. So the first thing that you notice here is that until a disaster occurs, we don't route traffic to the disaster recovery region, as services and resources are kept idle there or they're turned off. But having said that, you have the option to quickly provision the full scale of your production environment by switching on the resources that are currently turned off. So that's a very good thing as well. And for data replication, we can create Aurora replicas by making use of the AWS Aurora global database that gives us the feature of asynchronous cross-region replication. We already have a video on the Aurora database. Please go through that to understand more on how the replica works. For the routing, we can also make use of global accelerators, and based on the health check, it can direct traffic to the appropriate endpoint. And as we already have mentioned before, if you see the application servers are turned off here, And we can also make use of Cloud Endure for our disaster recovery as well if we wish to have our data centers or on-premise locations restored onto the cloud. So now let's come back to warm standby. So this is similar to Pilot Light, but the main difference here is that you can see the resources and the workload that you have in your standby location are scaled down. But having said that, unlike Pilot Light, this environment with warm standby is completely functional, but it's a scaled down version of it. So in other words, it is like less powerful than the actual environment. But don't get confused here. It's a copy of the actual environment, but just a less powerful one. And when you have a disaster, or if you want to support more users or traffic, you can also allow routing to this region by just scaling the resources that you have. Currently, if you see, the Route 53 is inactive for the production traffic, but if you want, you can also route the traffic by allowing the traffic through this. And if you want to support more number of traffic, then you can also scale it up. So on the right hand side, you can see it is mentioned minimal instances running. So we just need to scale it up to match the production environment. So I hope you understand the difference between warm standby and Pilot Light. So on Pilot Light, the services are turned off completely, but in warm standby, it is scaled down. So now we reach the most expensive disaster recovery strategy. I'm just kidding, but it's very expensive, but actually provides you zero downtime and near zero data loss. So with multi-site active-active, you can run your application in both regions simultaneously, and that is the active-active strategy. But there is one more advantage here. So as we mentioned, or as we discussed just now, with multi-site active-active, you can serve traffic on multiple regions at the same time. That's obviously an advantage. So, but having said that, you can also serve traffic from a single region. That is called hot standby, active passive, where you have an application hosted on multiple regions, but you can choose the one region that always stays active to serve the traffic. But you might have a doubt here that if you have to use hot standby, it's better to go with the warm standby. At least we'll save some money, isn't it? Yes, you are absolutely right. So if you're using active-active, go with that. Else, going to hot standby doesn't make much sense. And in active-active, you might feel, what is failover in this scenario? So yes, there is nothing called failover. It's just traffic redirection, and that's what we test when testing for disaster recovery with site-site or multi-site active-active. For replication, obviously we can make use of DynamoDB global tables, and you can route the right transaction to the closest region that you have and also use it for continuous backup. At last, we reach to the final step, that is step number 10, detection and testing your disaster recovery strategy. So let's see how we can do that. So for detection, you can make use of the personal health dashboard, which will provide you alerts and remediation guidance when AWS is experiencing events that may impact you. So why this is a very good service is because with the personal health dashboard, you get the personalized view of the status of the AWS services that are a part of your AWS resource list. And you can integrate it with Amazon CloudWatch event so that you can create custom rules. And based on that, you can trigger actions using Lambda to apply the remediation steps. So if something happens, you can do that. And if you can see here, I have mentioned it rightly that it is important to know as soon as possible that your workloads are not delivering the business outcomes that they should be delivering. So you must always be aware of what is going on in your environment, if it is functioning properly or not. And this is one of the most important steps for disaster recovery strategies. And with personal health dashboards, you get the event log where you can see if there are any services or any issues with the services that you are currently using on AWS. So that's a very good thing. So make sure that you use it and use it to your benefit to identify what are the things that are going wrong or if they are functioning properly or not. And you can see here we have operational issues and you see the status has been closed. So these are the issues that have been resolved. Now that we have detected it, let's see how we can test it. So when it comes to testing, it's more about testing the disaster recovery strategy that we have so that we can test and validate the failover to ensure we meet the RTO and the RPO. So you might ask, what is the use of testing the strategy? So in case you have a resource that you have like a data store or auto scaling group that doesn't provide any added advantage when you have a failover, so you can as well reduce it or increase it based on what your requirement is. So if in case your disaster recovery is not able to handle the load or it's beyond the capacity level that it needs, then you can change it accordingly. So that is why we test disaster recovery strategies. And to manage your configuration changes, you can use AWS config. So by using AWS config, we can monitor the AWS resource configurations that we are currently using. And that is also known as managing configuration drift. And you might ask me, like, what is actually managing configuration drift? So if there is a drift, so drift in English means like changes, isn't it? So if you think about your data center, there is a lot of changes that can happen over time on your configuration. So maybe due to the hardware or software dependencies, so it can change over time. And if in case there is a configuration drift between your primary environment and the disaster recovery environment, we should be able to identify that so that we can act upon the changes in order to keep it identical, isn't it? So if there is a configuration drift, we should be able to identify it, and AWS config can help us do that. So I hope you got the point. Let's move on. So this is it. We are done with the 10 steps of disaster recovery, and I hope you got the idea of how disaster recovery works for AWS or with AWS. And you can read more about this in the documentation. And if you have any suggestions or clarifications, please do let me know in the comment section below. And these videos really take a lot of time and effort to make. So please support this channel by hitting the subscribe button and giving it a like. It's free, so please do that. I'll be really happy. So that's it for today, everyone. I hope you are sound, safe, and healthy. I'll meet you in the next one. Until then, it's Pythoholic signing off.